So I've decided what x, y, and z represent. They represent the first, second, and third numbers. I used the first sentence in problem 6 to get the first equation. The sum of the three numbers is 5. The second sentence says the first number minus the second plus the third is 1. The first number minus the second plus the third is 1. So I have this equation. The last one says the first minus the third is 3 more than 3 added on to the second. So the question is, what should I do? And I could start to figure out what to do, except I like to have my equations written in standard form, like the previous problems from section 8.4. So I'm going to take the time to do that. The first two are already in standard form, so that's pretty nice. Here I need to do a little work. I'm going to subtract y from both sides, and I'm going to get this. And now the question is, what do I do? And the answer is, well, there's lots and lots of things I could do. I'm going to create a plan to eliminate z's. So I numbered my equations 1, 2, and 3. I made a plan that eliminated z's. Here it worked just fine, but here it also got rid of the y's, and so I have x is 4. Armed with that x is 4, I can go over here and figure out what y is. I have 8 minus 2y equals 4. So negative 2y equals negative 4y equals 2. And so I have the first number, x, is 4. The second number, y, is 2. But I know that when I add up all three of them, I have to get 5. So this one better be negative 1, so that when I add up all three of them, I get 5. And so we're done. So I've written down what my variables represent. X, y, and z, first, second, and third number. Don't skip that step. Then I've translated each of the sentences, and I'll let you go through that. Notice 2 less than means subtract 2 from. And so you can check that out. Now I'm going to organize them in standard form because I'm used to seeing things in standard form. So it's possible if you're going over these solutions that you're getting a little better at this. So let's just take a look at this plan. If I number these 1, 2, and 3 so we can start talking about plans, just think for a second what happens if we do 1 plus 2. No big plan, just 1 plus 2. Do you see both the y's and the z's disappearing? That's a pretty cool thing, so let's try it out. We get 3x equals 24, so x is 3. That's a pretty nice situation. We know that the first number is 3, almost for free, but not quite. Now what happens if we try adding 2 plus 3? It looks like the z's are going to disappear, so let's check it out. We might be getting better at the planning after we do the planning in quite a few problems. So here we add, the z's disappear like we thought, and we've got 5x's minus 2y's. But now we have the x is 3 that we can substitute in. 5 times 3 is 15, minus 2y equals negative 2. I'm going to come up this way, subtract 15 from both sides, and I've made a mistake. So I am going to fix my mistake. I've decided here that x equals 3 for no very good reason at all, just a complete ridiculous thing. Maybe I was going too fast, I don't know. But x is pretty clearly 8. I mean, I hope some of you caught that, but I certainly didn't. So now I'm going to put an 8 in here, and I'm going to bring it over here. So 5 times 8 is 40, minus 2y equals negative 2. I'm going to subtract 40 from both sides and get minus 2y equals negative 42. Divide both sides by negative 2 and get y equals 21. Now I have x and y, and I have this first equation, for instance, but I'm going to use this equation because it says z equals, and I like that. So z equals the y value minus 3 times the x value, which is 3 times 8, which is 24, so z equals -3. So the first number is 8, the second number is 21, the third number is -3. So I've started out once again describing what my variables x, y, and z are going to represent. X is the measure of angle A, y is the measure of angle B, z is the measure of angle C. These are all in a triangle. Now you need to bring some knowledge to this problem. The three angles of any triangle always add up to 180 degrees, so we got x plus y plus z equals 180 without the book even really telling us. Then in problem 9 it goes ahead and says the measure of angle B, which I've described as the letter y, is 3 times the measure of angle A. So we have y equals 3x. It says the measure of angle C, which is z, is 20 more than 20 added on to the measure of angle A, which is x. And then it asks us to find the angle measures. Well, we've got 3 equations and 3 unknowns, and I could put them in standard form, except I noticed something. If I were to replace this y with what y equals from the first equation with 3x, so I'm rewriting this equation, and now I'm going to substitute in what y equals in terms of x, and I'm going to substitute in what z equals in terms of x. So I have x plus what y is, plus what z is. I just noticed that I'm going to get an equation with one variable, x, and I like that. X plus 3x plus x is 5x. Plus 20 equals 180, subtracting 20 from both sides, I get 5x equals 160. Dividing both sides by 5, I get x equals 32. So the measure of angle A is 32 degrees. Then I can put in a 32 right here and have y equals 3 times 32, which is 96 degrees. And I can put in my 32 degrees for x here and find out that z equals 32 plus 20, or 52 degrees. So x, which is the measure of angle A, is 32 degrees. Y, which is the measure of angle B, is 96 degrees. And z, which is the measure of angle C, is 52 degrees. And these are the 3 answers. And that one worked out pretty well. I kind of liked it.